Hi, in this video we're going to talk about how we describe key attributes of functions, mostly talking about maximum and minimums and X and Y-intercepts. Alright, just to get some of the terminology down, I'm going to start with this graph that doesn't even have numbers. I'm going to start this graph by labeling any point with an A that is an X-intercept. And remember, X-intercepts can also be called roots, zeros, or solutions. So as you can see, this graph has a lot of x-intercepts, 1, 2, 3, 4, 5, and it's anywhere that we hit the x-axis. Alright, so now I'm going to place this B at the y-intercept. This is where it hits the y-axis. Okay, now for something new, I'm going to label C at every local max. Local maximums are the highest points in their little areas. To get a local max, a function has to go from being increasing to decreasing. So this function has two local maximums. This function does not have an absolute maximum because the graph continues growing. Just like the local max, I'm going to put a D at these local minimums. And again, this graph does not have any absolute max or mins because those would be the highest or lowest points, and this continues growing more and more negative or more positive. Take a look at this graph and ask yourself these questions. Can I identify the zeros, the y-intercepts, the local max and min over the whole graph, or what about just the local max on this interval from 0 to 6? Pause the video, draw this graph, and see if you can identify all those things, and then just come back here in a second and check. Okay, hopefully you identified the zeros as -5, 0, -3, 0, 2, 0, and 4, 0. The y-intercept would be here at 0, -2. The local max would be here at -4, 2, let's say 2, and 3, 3. The local min would be here at probably -1, -2. I'm sorry, I'm not great at drawing these. But the local max on just an interval, so from 0 to 6, that's from here to like here. The local max in that case would just be 2, 3. Let's talk about finding x and y-intercepts. So think about this. At an x-intercept, what does y equal? At an x-intercept that's on the x-axis, y equals 0. And at a y-intercept, what does x equal? X equals 0. So we can use that to solve for these things algebraically or whenever we're just looking at a table. Algebraically, let's find the x and y-intercepts. So to find the x-intercept, set y equal to 0. So we say 3x minus 9 times 0 is equal to -18. Well, obviously, -9 times 0 is going to disappear. So if 3x is equal to -18, I can say that x equals -6, giving me an x-intercept of -6, 0. So to find the y-intercept, I'll just set x equal to 0. And so 3 times 0 is going away. If -9y equals -18, dividing by -9 on each side gives me y equals 2. So I have a y-intercept of 0, 2. And just for fun, I went ahead and graphed the function, and look, there they are, -6, 0, and 0, 2. If you're asked to find specific x and y-intercepts from a table, well, just think, at a y-intercept, x equals 0. Look right here, that x equals 0, so this must be a y-intercept. And at an x-intercept, y equals 0, so this must be an x-intercept. But what if it wasn't that clear? All right, so here we have a table of a linear function. That's a line. That means its slope never changes. It can't go down and then start coming back up. And we're trying to figure out between which two x values did the x-intercept occur. What it's really saying is, when did y equal 0? Well, we can see right here that the y values went from positive to negative. That means that they went across the x-axis. So between which two x values did the x-intercept occur? 1 and 3. All right, and that's just about going to wrap it up for this video. All right, goodbye.